Okay, so I'm going to talk about central angles. So looking at our example here, we already know what a central angle looks like. So we have an angle that's vertex is on the center of the circle and is formed from the two radii. And we also know that there's an arc here that we say is being intercepted by the central angle. Okay, so that arc. And let's just say that this is the vertex is B and C. So our central angle here is angle ABC. And our intercepted arc is arc AC. Okay, so what we know about central angles is that the measure of a central angle is the same or equal to the measure of the arc that it intercepts. So in other words, if this angle ABC, has a measure of, let's say, 60 degrees, then arc AC also has a measure of 60 degrees. So that's all that's saying. So any central angle that I draw, so if I draw, let's say, if I just continue this and I call that point D, now I have a diameter. Well, the angle measure we know of a line is 180 degrees. Okay, so arc AD also has a measure of 180 degrees because arc AD is the intercepted arc from line segment AD, which is the diameter of the circle. Okay, so that's how central angles, the measure of central angles works. So let's take a look at a few examples. So it says calculate the measure of the following arcs. So the measure of arc AB. Well, we can see here that the central angle is 120 degrees, which means the measure of arc AB is equal to also 120 degrees. Notice the way we write that, the measure of arc AB. Very similar to how we wrote the measure of an angle, okay, except for we use the arc symbol. So the measure of arc AB. The measure of arc EF, we can see here in this second diagram, the central angle has measure 90 degrees, therefore the arc also has measure of 90 degrees. Now, measure of arc ACB. Remember, we talked about major arcs before, so when it has 3 letters, I know that it's referring to this whole entire major arc ACB. So, if the whole entire circle measures 360 degrees and the central angle, angle AOB, measures 120 degrees, that leaves me, if I subtract 360 minus 120, that leaves me with 240 degrees for the angle that's created here. So if the angle is 240 degrees, then so is the intercepted major arc. So that's 240 degrees. Next, EGF, arc EGF. So same idea, we're talking about the major arc. Okay, so if 90 degrees is the angle measure of angle EOF, that means that the other angle, the obtuse angle, would be 360 minus 90, which is 270. Okay, so that's the angle measure there, which means the intercepted arc is also 270 degrees. So let's look at a few more. So if the central angle measures 57 degrees, then so does the intercepted arc. Okay, here, let's make sure you understand what's happening here in this diagram. What it's showing is that the angle X is what we're looking for, and that's everything except for the central angle. So, and then it's also showing us that the intercepted arc starting here and ending here, the intercepted arc measures 280 degrees. So the point is, if the intercepted arc is 280 degrees, then the central angle, in this case the obtuse angle, not this angle here, is going to also measure 280 degrees. So x is 280 degrees. Next. So this time we're told 280 degrees, but we want the central angle, and we're talking about this acute angle there. So I'm going to subtract 360 degrees minus 280 degrees, and I'm going to find that x is equal to 80 degrees. And the last one. So it says for circle O, the measure of angle 1 is equal to the measure of angle 2. So I'm going to mark that. I know that. And I'm supposed to figure out what the measure of the angle marked x is. Well, I can see that angle 1 has a measure of 62 degrees because it's a central angle and the intercepted arc is 62 degrees. So if I know that 1 is 62 degrees, then I also know that 2 is 62 degrees. And I can see also that we have a diameter here. So that means the intercepted arc of the diameter will have measure 180 degrees. So if I already have two 62s, I'm going to add those together to get 124 degrees. And I'll subtract that from 180 to find the measure of not only this intercepted arc here, but also the central angle marked with an X. So that gives me 56 degrees. So the measure of angle X is 56 degrees. And that's how we use the idea of central angles and the intercepted arcs having equal measures.